Today we're going to do a little bit of review from geometry of angle of elevation and depression. First of all, angles of elevation and depression must come from the horizontal line, never from a vertical line. So angle of elevation would look something like this, the angle from looking straight out and up. So this would look like an angle of elevation. Angle of depression would be the angle formed from looking straight out and down. So this would be an angle of depression. Now I have a picture drawn down here of something like you might see in a problem that will work here in a few minutes. You may have a rectangle and you may have something like, have a little smiley face here to represent maybe a person up and maybe a building or something. They're up high looking down at somebody down low, and you have both an angle of depression and angle of elevation, and it's really important that you can put the angles of elevation and depression in the correct place, and this is where we always see the big mistakes. So if this smiley face is looking down at this smiley face, think about where the angle of depression would go. Remember, it's the angle formed from looking straight out and down. So this right here would be the angle of depression. Here's where everybody wants to put it, right here. It's not here. Okay, this is not depression. It's not this one pointing down. Do not put your angle of depression there. And the angle of elevation is the same angle, well, we'll talk about measures here, but the angle of elevation is the angle from this person looking up at this one. So it's the angle formed from looking straight out and up. So this is your elevation. And whatever the angle of elevation and depression is, let's say it's maybe 30 degrees. If this person is looking at an angle of 30 degrees up at this one, let's say this angle of elevation is 30 degrees, then this angle of depression is also 30 degrees, because you know from your rules of rectangles that these angles would be the same. So just remember that this is not where your angle of depression goes. That's the biggie. Okay, let's try a problem applying this information. A person at one end of a 230-foot bridge spots the river's edge directly below the opposite end of the bridge and finds the angle of depression to be 57 degrees. How far below the bridge is the river? Okay, so we have a bridge, and we have, let's drop off down here to the river, and here's the river, and here's our bridge. I know a lot of you can draw a whole lot better than this. I am not artistic at all. So there's our bridge, and we have our person right here. And this is the opposite side. Well, I'll put that up here in just a second. So this person is looking at the opposite end of the bridge. Okay, so this person is looking at the opposite end of the bridge and looking at the river's edge directly below. So they're looking at the river right down here. So this is where they're looking at the river's edge directly below the opposite end of the bridge. And they find the angle of depression. So this person is looking straight down here. That's supposed to be a straight line. Is looking straight down here at this river's edge. This is our river. So the angle of depression, we just discussed where angle of depression goes. Let's put that in the correct place. Our angle of depression is right here, and that is going to be 57 degrees. Okay, 57, erase my word bridge there. All right, 57 degrees. All right, 57 degrees. Bridge. Alright, what else do we have? The bridge is 230 feet long, so from here to here is 230 feet. How far below the bridge is the river? Well, I want to know this distance right here. This is what I want to know. Now we need to think about how we're going to figure that out. We're going to use our trig ratios, opposite, adjacent, and hypotenuse. We need to figure out which trig ratio to use. So this is our reference angle here. In reference to this angle, let's label our triangle opposite, adjacent, and hypotenuse. Well, this is going to be our 90-degree angle. So in reference to our 57 degrees, what I'm looking for is opposite. 230 feet is adjacent, and this is the hypotenuse. So what I'm looking for is opposite, and I have the adjacent. Opposite and adjacent is tangent, so I'm going to use tangent of my angle, 57 degrees, equals opposite, I'll just call that x, over adjacent, which is 230. Now, before we go any further, check your calculator real quick. We are dealing with degrees, so make sure you are in degree mode. If you're in radian mode, all of your answers will be wrong. Now, some of you are better at this than others, but just for safety reason, if you are not too good at these, you may want to put this over 1 and think of this as a proportion and cross multiply, because sometimes you're going to multiply these numbers together, sometimes you divide. So think of it as a proportion. Tangent of 57 times 230. So tangent of 57 degrees times 230 equals x times 1, which will be x. So this one was an easy one. You're just going to multiply tangent of 57 degrees times 230, and let's give a couple of decimal places. So that's 354.17 feet. So that's how far down the river is from the bottom of the bridge. Okay, in our second and last example, a passenger in an airplane at an altitude of 10 kilometers. So that means the altitude, the height right here of this plane is 10 kilometers. Sees two towns directly to the east of the plane. The angles of depression to the towns are 25 and 55. No, I said 25, sorry, 28 and 55. How far apart are the towns? So ultimately, I'm wanting to know this distance right here. I want to know how far apart are the towns. So it's going to take a couple of steps or a few processes to get there. So the angle of depressions to the towns are 28 and 55. Do not stick the 28 and the 55 right here, because remember, we're doing angles of depression. So you might want to draw out like a rectangle here, the angle of depression from the plane. Let's do this outer town, this one, the furthest out one. This would be your angle of depression. Now remember, the angle of elevation is the same as the angle of depression. So I actually find it a little easier to redraw this, because this would be our angle of depression. So what I'm going to do to make this a little bit easier, sorry, my pen is going nuts there. This would be depression. So what I'm going to do to make this a little bit easier is I'm going to draw two separate triangles, one to represent each town. Okay, so this is, I'll just call this town A and town B. So town A is closer, town B is further away, and then here's our plane. P for plane. Alright, 90-degree angle. Alright, so let's look at it this way. Angle of depression, remember, is the same as angle of elevation. We discussed that over here with the smiley faces. So, let's think about this. The further or the closer you get to something, the more you're going to have to lean your head up to look. So think about which angle needs to be bigger, to the closer the town is to the plane or the further away you are to the plane. Think about the closer you get to something, the more you have to look up. So the closer you're going to get to the plane, the more you're going to have to lift your head up, so the bigger the angle is going to be. Now I know my triangles aren't drawn to scale, but the closer town is going to be the bigger angle. and the further town will be the smaller angle. So this will be my 28 degree. Okay, those would be angle of elevation, which would be the same as angle of depression. The plane is still 10 kilometers high. Now if I will figure out how far town A is away from the plane and how far town B is away from the plane, not this distance but the horizontal distance, then all we have to do is subtract the two and then we can find this. So let's figure that out real fast here. 55 over here is opposite. This is adjacent. Same with this triangle. This is opposite. This is adjacent. So we're using tangent on both of them. Okay, so this is going to be tangent of 55 equals opposite, which is 10 over, I'll use x for this one, and I'll come down here and use y for that one. Alright, now this one is a little different than the one I just did with you, because this one, if you put tangent over one and cross multiply, if you cross multiply here, you're not going to be multiplying 10 times tangent of 55. So watch what happens. Tangent of 55 times x equals 10. And then to solve for x, you have to divide by tangent of 55. So this one you end up dividing. So in your calculator, you need to do 10 divided by tangent of 55. And this one ends up being, let me do some little squigglies because this is approximately, I should have done that on the other one too. We're going to approximate because we're rounding. This one is about 7 kilometers, even rounding. Okay, so that's town A. This distance right here is about 7 kilometers. So let's do town B. Opposite and adjacent. So tangent of 28 degrees equals opposite over, I'm going to do y this time for this one. Put that over 1, cross multiply. Tangent of 28 times y equals 10. Divide by tangent of 28. So y equals, do 10 divided by tangent of 28, and that one will be approximately 18.81 kilometers. Right, so that is this distance right here, 18.81 kilometers. So, how far is town A from town B? Well, if you'll take 18.81 kilometers, subtract the 7 kilometers, then that tells you that the towns are about how far? 11.8 kilometers apart. So let me come back over here to this one. It's not that big a deal, but that's approximately because we're rounding. So there you go. There's how that works. And there's a quick review of angle of elevation and depression.